So we're going to get started, which means that I need your attention up here. So I hoped that I would have your quizzes graded today, and I have them about halfway done. So if you guys are working for a while and I can get them graded, then I will get them back to you today. Otherwise, I'll get them back to you tomorrow at the very latest. I wanted to spend a little time today kind of reliving in super fast forward mode trimester 2, so that you know what we did. And going back, I was like, wow, we did a lot, which is really cool. But also so that you know what's coming up on Thursday, which is in 2 days, on the final, right? So I went back through, and you may want to get out a piece of paper so you can write this down. Maybe not, I don't know. But I went back through and wrote down all of the standards that we've covered in this trimester, okay? So we did 3 units. The first one had 4 standards. The second one had 3 standards. And then the last one was just our kind of quick circular motion unit. So it was just that 1 standard, okay? But these are the standards that we will be assessing, that I am giving you final scores over for this trimester, and that you have the opportunity to make, to improve your grade on. Okay. So I just wanted to kind of go through them with you, just kind of remind you where we were at, what we were doing. I'm not going to take tons of time because I would like for you to focus on the ones that you want to focus on, that you need to focus on. So you got 7, 8 of them. I'm going to say that, and I haven't written it out, so I don't want to swear to things. I'm going to say that you need to pick 3. I think 3 is fine. Yeah. And if you want to do more when you're doing your final, then you can do more. If there are a couple you're like, oh, I'm not sure, then do them, right? I would rather that you take advantage of the way that this system is working to ensure that your grade is as high as possible, right? You have control over it. You have the opportunity, I guess. So everyone on Thursday will take standard 2H, which is the circular motion standard. That's the one that you just took the quiz over. Like I said, I'll get that back to you as soon as I have them done. But everybody's going to do this standard because I need more than 1 data point in order to give you a standard score. Okay? So everyone will do this. And then you can pick 2 or 3 or 4 or 5. You can pick as many as you want, other standards to reassess. Okay? But you will have to do at least 3. Does that make sense? So when I give you the test, it will have all 7 of those, 8 of those with questions written out for them. And you can pick day of. You don't have to tell me, beforehand.
So when we get the final, we don't have to do 2C if we don't want to do
Nope.
2C.
Nope. So I'm giving you the opportunity to take control over what you have. So in just a minute, after I'm done talking, if you haven't already looked on PowerSchool, you can look on PowerSchool and see where you're at. And I have given you final standard scores for every single standard except circular motion, because I haven't put that one in yet. Okay. And if there's something outstanding, I don't really think there is for anybody, but if you feel like there's something I'm missing, then I can certainly do that. But I went through yesterday and made sure that everybody has a score for each standard. Okay, so you can look through that. And that means that every single one of you can do any iteration of it that you want. Okay, so if Maya's like, whoa, that conservation momentum stuff, I kind of got it, but my standard score, and I have no idea, I'm just picking on you, right? Maybe my standard score is only a 4 out of 6, right? Maybe that's one of the things that I want to focus on in the next 2 days, because it's been a while since you've done it. But you can master any of these in 2 days. I totally believe in that. I totally believe that you can. Okay? So it's going to be up to you to figure out what you want to do. Does that kind of make sense? Yeah. Okay. So just to kind of get your brain around this. So Newton's third law, we remember this. So maybe why don't you get a piece of paper out? We'll just write these down real quick, just so you can get this in your head again. You're like, oh yeah, that's totally that thing. And then when you look back on PowerSchool, you can figure out if that's what you actually want to study. So Newton's third law, conceptual. What's the big picture? what were we really trying to show and tell there? Do you remember? Long time ago, yeah.
I push on the table pushes back on me.
Yeah. Newton's third law in all its glory says that the force of A on B equals the force of B on A. Always and forever. That's right. Over the long snow day time that we had, my kids and I were watching a bunch of ice skater type movies, and I kept thinking of you guys. Like every single time I'm like, oh, physics, right? It's all there. The force of A on B equals the force of B on A. That's it. I mean, that's like the quintessential piece there. And we remember that the acceleration of A might not equal the acceleration of B, but that the forces that they're experiencing will always be the same. A force takes two objects. Force of A on B will always be the same as the force of B on A. It'll be the opposite direction, so you could put a negative sign in there if you wanted, but they will always be the same magnitude. So that's standard 2A in a very tiny nutshell. Graphical analysis of motion. This one I was like, what was that? I had to look, but I remember now that the graphical analysis of motion standard, that one was about like talking about collisions. Do you remember we had those carts on the track? And we had one cart going and then it would bump the other cart, or you had the two carts coming together and then they would come apart. So this graphical analysis of motion was collisions, or I should say graphing collisions. We'll say graphing D versus T graphs. And then describing the motion. Yeah, the elastic and inelastic collisions. So you had, like, for example, here, I'm going to see if I can throw some space in here. Will that work? Not quite. No, it's not going to want to go. You're not going to do that? No? Okay, whatever. So this one was like, you know, maybe you had one cart that went like this and then like that, and another cart that came in like this and then went like that. Does that look kind of familiar? Again, it's been a while and I totally get that. And so I'm not trying to be like, tell me the answer right now, but just kind of a friendly reminder of what we were talking about. And so in this case, you know, this cart was not moving and then it started moving after the collision. This cart was moving at a constant speed because it's got a constant slope, right? And then after the collision, it stopped. So describing those collisions or drawing a graph based on the collision, that kind of thing, okay? Telling me which one has more mass based on their speeds, that kind of stuff. Conservation of momentum. Actually, let me back up. Is that okay for 2B? Does that ring a bell? Standard 2C, the conservation of momentum standard. This was the one, so the game here is that the total momentum at the beginning has to equal the total momentum at the end. And that means that if you have two carts that are interacting, then you've got the momentum of A plus the momentum of B at the beginning equals the momentum of A plus the momentum of B at the end. This one was the one where we had those charts that we filled out, the charts for the problem solving. I can see if I can hunt one down. I meant to do this and then got distracted. Let's see, did we do one? I can't remember when we did them. Practice problems. Oh, here, chart for problem solving. There we go. Like this stuff. Yeah. It's been a while, right? December 6th. Like that was a long time ago. But yes, that's what we did. And again, when you're looking back at Power School and you're like, I guess that's something I need to do, I don't want you to be scared away and be like, I haven't done that for 3 months. Because I can help you with it, right? We can look at examples and we can get back in there and we can get your brain back to it. Okay, if that's one of the things that you really want to focus on. But that's what we're talking about. Those are the charts that we did. Okay, so I'm just going to put chart problem solving here. Okay, that was one of those things that I feel like most of you, once we kind of set it up in that chart, felt pretty good about. But again, if that was something that you want to go through again, you know where to find me. We'll go through it. Okay. And then standard 2D, that was the impulse momentum theorem. Do you remember? This one was a while ago too. So yeah, go ahead.
We found that one, doesn't actually start with P.
Yeah, I think we found out later, didn't we? Yeah. That the change in momentum is equal to force times time, right? So this was the one where we talked about something slowing down, like with an airbag versus no airbag, right? Or the egg drop. This is where we did the egg drop. So you had all of that cushion there to stop the egg in as much time as possible. You give it more time, that means less force. Okay, so this was the impulse momentum theorem. So I'll just put that little reminder there, right? This was like the airbag. This was also the egg drop. We have done a lot of stuff this trimester, you guys. I don't know if you've like thought about that or realized, like we've done so much good physics. It's pretty awesome. It's pretty awesome. Yeah. So that was all the first unit, which was kind of a big old unit, okay? Questions on that standard 2D? Then after that, we started the next unit, which this now feels much more recent, at least to me. Work and power. So again, just kind of getting our brains back in here. So that was work is equal to force times distance. And then you could also think about it as the work kinetic energy theorem or the work energy theorem. And then we had power was equal to work divided by time. One thing, and I don't know if you ever like saw this, I didn't point it out because I don't usually like to like confuse you while you're in the middle of things, even though some of you think I do try to confuse you on purpose. I don't, I really don't. Work is force times distance. Change in momentum is force times time. They're very similar looking things, right? When you change the time, though, it's affecting the momentum. And there's some nice things to kind of show that these are very much related, but we're going to kind of compartmentalize them into two separate things. So change in momentum or impulse is force times time. Work or change in energy is force times distance. So those were the big deals there. We did types of energy. Do you remember what kinds of energy we talked about in the types of energy section? Yeah. We had kinetic energy, the energy of motion. We had gravitational potential energy, which was the energy related to how high up something is, above an H equals 0. And we had elastic potential or spring potential energy, which was that 1/2 kx squared. That K is the spring constant, right? That's why we did the Hooke's law thing, was to kind of get our heads around what that was. And there's a lot of conceptual stuff in here as well. I'm just kind of writing these things down to jog your memories, to kind of keep that all, the juices flowing there. And then the concept of conservation of energy. This is basically saying that in a closed system, the total energy is always the same. Or another way to say that is the energy total at the beginning is equal to the energy total at the end. It can absolutely change forms, but it's one of those forms, right? It's always going to be there. I forgot one type of energy there, right? That thermal energy was the force of friction times the distance. Sorry about that. And again, we have a nice similarity here between your total energy is the same at the beginning and the end, and the total momentum is the same in the beginning or the end. So there's some nice symmetry there, which is kind of cool to see. And then that circular motion unit, I'm just going to keep cruising if that's okay. Is that good with everybody? Circular motion. So this was the centripetal acceleration, v squared over r. A centripetal force is anything that's keeping it in a circle, right, is m times a sub c. Okay. Vt squared, I suppose. So we have done kind of a lot of stuff this try, which is pretty awesome. I also, can I move this? Is that okay? I also pulled up my equation sheet just to kind of see, so you could get a sense of what stuff you're looking at. So if you want to look at that just to kind of orient yourself to what you might be looking at on as you're studying. So the first unit, the big stuff is right here. Boom. Okay. It's just momentum and impulse. The second unit is right here, all this work and energy stuff. And then the third unit is the rotational motion. And we did not get to gravity. I think we'll start off with that next week, just because it's cool and I want to make sure you see it.
So we're supposed to get that then.
I was hoping, yeah, but then we had that snow day and it kind of got us messed up. So it's one of those things that I don't want to do it poorly. I would rather like commit the time and do it. So I think we'll do it next week, just for a couple days because it's interesting. So is that making sense to people? Okay. So my thought, like if I was sitting in your position, I'm thinking like, okay, so now I've got a sense of what we did this trimester. Now I need to figure out what I need to study, right? And again, that's going to be different for each of you because your final will be what you want it to be, right? So again, you can do, let me put it this way. If your grade is not where you want it to be, you right now have control over that, okay? Because you could test all of these standards. Now, I don't know that you could get all of these standards done in one Thursday sitting of our final, but if you come to me and say, hey, Ms. Carling, I really want to assess 5 of these 8 standards, and I'm not sure that I can get them done, then we can talk and we can come up with a plan, right? Like, why don't you do 3 or 4 of them in class and then we'll figure out a time for you to come in and do the others. That's absolutely fine with me because I want you to have control over how you do. Okay? So I'm going to give you some time right now to hop on Power School, to make a plan, okay? And I'd like you to actually commit to that. I would like you to spend time today not on your phone and not doing your Spanish homework and not studying for your math test. I want you to actually work on physics, okay? I have your old quizzes and tests, and if you would like those, I can hand those out so you can look at those. All of the assignments that we have done over this this trimester, like all of the homework assignments are up on Canvas, so you can look those up and you can get a book and start working on homework, okay? Use this time resourcefully, okay? Work with each other if you want, or work by yourself. I don't really care. Does that sound good? Okay, awesome. Do your thing.